Computers of today are capable of doing things that are unimaginable even a few years ago. Now the Google team claims a quantum computer has completed a computational task previously unattainable with conventional computers for the first time. According to Google researchers, Google Quantum AI PA is capable of surpassing supercomputers. This significant advancement in computer capability was announced recently. So let's see how and what did the Google's insane quantum computer instantly execute a task that takes 47 years. There's no doubt that quantum computing, a field of science that makes use of the peculiarities of quantum mechanics, remains one of the most rapidly moving and contentious fields in the world today. The scientists hope to be able to speed up machine learning, solve climate change, and discover new drugs based on the strange properties of quantum physics. Experts believe that within the next couple of decades, quantum computers will replace the traditional computers we currently use at our desks and revolutionize our way of life in the process. It's important to understand that traditional computers use bits, which can either be in a state of 0 or 1. Quantum computers, however, use quantum bits, or qubits. Because of a quantum principle called superposition, a qubit can exist simultaneously in both states. A quantum computer can be overlaid to increase computing power exponentially. For example, 2 qubits can exist simultaneously in 4 states, 3 qubits in 8 states, etc. This enables quantum computers to process a massive number of possibilities simultaneously. In quantum computing, entanglement is another key principle. Qubits that are entangled are deeply interconnected. When you change the state of one qubit, you change the state of the entangled partner instantly, regardless of the distance between them. Quantum computers can use this feature to process complex computations more quickly. The quantum computer utilizes specialized hardware and quantum algorithms to take advantage of quantum mechanics unpredictability. In a nutshell, quantum computers use electrons, photons, or other subatomic particles and place a classic computer's binary language of ones and zeros and electric impulses. As what is said, these particles can exist simultaneously in 2 different states within quantum bits. Thus, quantum computing differs from electronic computing because particles can either be a 1 or a 0. Due to their faster calculation speed than traditional computers, quantum computers remain largely experimental, have a number of challenges to overcome. In spite of the steady progress made over the years to develop a practical and capable quantum computer, Google's latest breakthrough represents a significant advance. It's been reported that Google has built a quantum computer that can execute calculations that normally take nearly half a century on the world's most advanced supercomputers in mere moments. Researchers at Google have developed a quantum computer that can perform computations that used to take previous best supercomputers 47 years to complete. Researchers at Google have published a paper online which claims the company's latest technology expands the capabilities of existing supercomputers in a significant way and goes beyond what is available from classic supercomputers. A Google scientist published the results of the research on the prepress server RxIV, which is often used by scientists to distribute their findings before they are submitted to evaluation by an official publication. As part of their first assault on the quantum supremacy milestone in 2019, the team used Google's quantum computer called Sycamore, which consists of 53 qubits. When a quantum computer performs tasks far beyond the capabilities of a classic computer or supercomputer, it's said to be at a quantum supremacy. During the recent task, the scientists used an upgraded version of Sycamore, which consists of 70 qubits, to perform the computation. You already know that quantum information is represented by qubits, just as classical information is represented by bits. The additional qubits in the new processor make it 241 million times more powerful than its previous model. As mentioned by the researchers, the purpose of this experiment is to answer some of the questions that have been raised by these classical versus quantum competitions. Despite opposition at the time, Google claimed it had reached quantum supremacy in 2019. IBM countered that the task Google's Sycamore quantum computer was able to perform was not particularly difficult and could be completed by a classical machine. As of now, it's unclear how much it cost Google to develop the quantum computer, but according to them, the computational cost of the experiment is higher than existing classical supercomputers, even if using improved classical methods. It is speculated that quantum technology may lead to one of the most powerful computers in the world, in part because it makes use of the strange properties of quantum physics in order to dramatically speed up information processing. During the experiment, the scientists conducted a random circuit sampling task to evaluate the capability and efficiency of a quantum computer in solving complex problems. A quantum computer is tested by running random circuits and analyzing the outputs. As part of recent tests of the Sycamore quantum computer that consists of 70 operational quantum bits, Google engineers used random circuit sampling to collect readings that were generated randomly. Sycamore quantum computer was capable of completing calculations in a matter of seconds due to random circuit sampling, which minimizes the threat of external noise pollution affecting calculation results. For the calculations, they looked to the world's first ever exascale computer, the Frontier, to calculate the time it would take for a classical supercomputer to do the same. Frontier is capable of executing 1.1 exaflops per second, or 1.1 quintillion operations per second. Future advances could increase the performance to 2 exaflops per second. Google estimates that Frontier would take 47 years to do the same calculations, so Sycamore is 47 years faster than the fastest classical machine. Google's latest quantum system test shows promising results for quantum computing in the future, despite being far from an efficient and stable quantum computer. Furthermore, it defeats a recent demonstration from Chinese labs, one of the newest research groups to proclaim quantum supremacy. Using estimates of available computation resources and achievable fidelity bounds, the researchers conclude that their demonstration falls firmly within the realm of beyond classical quantum computation. Experiment receiving praise from researchers despite doubts about its practicality. It's been questioned how practical quantum computing tasks are in former quantum advantage experiments. In most cases, people do not need bosons or random circuits right away, but they do need cheaper medications. Interview with The Telegraph, Riverland's chief executive Steve Brierley said, "This is a major milestone. Squabbling about whether we had researched or indeed could reach quantum supremacy is now resolved. It is hoped that these obscure experiments will ultimately lead to more practical calculation equipment and practices. Though quantum computing is believed to be superior, many doubt its practicality. Since this is the first time these processes have been compared against each other, some have said the comparison of supercomputers to quantum machines is a bit suspicious. Despite this, the Google team retains its position that quantum computers are capable of processing processes that are way beyond the capabilities of classical computers. The new experiments also reveal how quantum noise, which is inherent to quantum computers due to their complexity and fragility, can affect processes as they run and sometimes can lead to new quantum phases. It is crucial to work through this noise to accurately record qubit states in quantum computers. Scientists have attempted to solve this issue in a variety of ways. In addition, the Google Quantum AI team used a quantum benchmarking protocol called cross-entropy benchmarking to identify phase boundaries that define noisy quantum evolution's computational complexity. The team reported in their research paper that noisy quantum processes remain a significant challenge despite the progress achieved with random circuit sampling. Google recognizes that there is still much to be done in this field, despite its new quantum computer being a great milestone. It is expected that the company will be able to build a quantum machine that consists of 1 million qubits by the end of the decade. Quantum computing is one of the most advanced technologies to date, but it's not without its potential pitfalls. Beyond the engineering difficulties, it's possible to encounter even bigger problems with quantum computing. The advent of quantum computers poses significant challenges for the development of modern encryption systems, particularly with the advent of mass quantum adoption. Quantum computers are capable of cracking even today's strongest encryption. This means that the country that gets there first will have a significant advantage, which can also a threat to national security today. A few critics of the quantum machines also argue these machines must demonstrate greater practicality outside of academia despite the impressive milestones they've achieved so far. It's also difficult to correct quantum errors because quantum bits are fragile, so they're more likely to cause errors in classical computations. It's still a key objective of quantum computing research to find efficient error correction algorithms without requiring too many qubits. In addition, quantum states are complex, and maintaining them for any period of time, known as quantum coherence, can be difficult. Decoherence, the loss of quantum states, can happen as a result of a minor environmental disturbance. What do you think of this insane quantum computer? Let us know in the comments below. Thank you for watching and see you in the next video.